We want to find the derivative of these functions. Looking at this first function, we see we have a function inside of a function inside of a function. Whenever we sort of use this shorthand notation for trig functions, when we're looking at this with chain rules and so forth, I like to write it out so we can really clearly see what is the outside function and what's inside. So our outermost function is a squared function. We essentially have the cotangent of some stuff squared. And then inside of that we have the cotangent of some stuff, and then inside of that we have the sine theta. So we're going to need the chain rule a couple of times. We're going to start with the outermost function and take the derivative. It's a power rule. Power out in front, decrease the power by 1. You do not change the stuff inside when you're working on the derivative of the outside function. So the stuff inside was cotangent of sine theta, and that's still there. Then we move inside, and our next function in is cotangent of some stuff. So we multiply by the derivative of cotangent of stuff. The derivative of cotangent is negative cosecant squared, but the stuff doesn't change because we are just working on the derivative of cotangent. Then we move inside of that. The derivative of what's inside is the derivative of that is cosine theta. So our final answer here, it looks like we have negative 2. Maybe I'll list the cosine theta first, and then we have cotangent of sine theta, and we also have cosecant squared of sine theta, and there really isn't a way to simplify that. Now the second function is one that we were working on earlier when we learned the product rule, and I started to show you a second way to do it and then said, oops, we don't know the chain rule yet, so we can't do it that way. Well, now we know the chain rule, so we're ready to do that. So the first way to do this would be to use the product rule, and this would be our first factor, 1 minus e to the z, and then z plus e to the z would be our second factor. Well, the other way we could do this is doing a little algebra. We could multiply this first, and so if we FOIL this, we would have z plus outers would give us e to the z, inners would give us minus z e to the z, and last times last would be negative e to the, keep the base, add the exponent, so that would be 2z. And then we could take the derivative. The derivative of z is 1, plus the derivative of e to the z is just e to the z. Here was our product rule. So first, which is negative z, times the derivative of the second, which is e to the z, plus the second, which is e to the z, times the derivative of the first, which is negative 1. And then this was the part where we were stuck before, because we have a function inside of the exponential. We have a 2z function. So the derivative of e to the something, it's negative here, is e to the something times the derivative of the something, so multiplied by 2. And that's not something we could do until we knew the chain rule. Now let's go ahead and see what we can combine here. And it looks like our e to the z's would cancel, and we would have 1 minus z e to the z minus 2e to the 2z, and that's what we should have gotten when we had done this previously using the product rule, but it's probably just a little bit easier to do it this way.